Technometry means we'll write it what is exactly the meaning of a technometry. Yes. So let us begin that. So this is a technometry. Technometry means tri means 3. Gono means it is a size, and metry means it is a measurement. This is a Greek word. Technometry, it is a Greek word. Tri means 3. Gono means a size. Metry means it is a measurement. Here we observe that there is a right angle triangle. This is a right angle triangle with sides. It is a A, B and C. This is a right angle triangle. This is right angle at B. So here it is 90 degree. Further, opposite to 90 degree, this will be the hypotenuse. It is denoted by H, and this we call it as a theta. Theta is a Greek letter. So in English or in algebra, in a last class we have discussed, we use x, y. All these are algebraic quantities. Like that, Greek, one of a letter is a theta. So opposite to this, we have a opposite side, and we left with the third side, that is adjacent side, or one more name for this. This is called as a base. So we have a 3 sides, opposite to theta, opposite side, opposite to 90 degree, hypotenuse, and third one we call it as a base or adjacent side. Okay, let us begin this concept with the technometry. Yes, we have a different angles. So standard angles, that is 0 degree. This is a little finger. This will be a ring finger. You can concentrate over here. This is a little finger. This is a ring finger, and then middle finger, index finger, and last one it is a thumb. So I assign a value. This is 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. Using this, we can write the standard angles over here that we will discuss. Hello students, a new chapter, ray optics. Okay, in first ray optics, the law of refraction. What is states refraction? We consider a medium, right? And normal. I'll incident the light from rarer medium to denser medium. By inserting light from rarer medium to denser medium, the part of light get refracted. Okay, that is known as what we call it is law of refraction. Okay, in law of refraction, here we have stated 2 laws, right? That is first law of refraction, and another one is second law of refraction. So second law of refraction, what we call it is a Snell's law. We call it is Snell's law, right? Okay, now what first law of refraction state? Incident ray, the refracted ray, normal, all lies on same plane. All lies on same plane is known as what we call it is first law of refraction. Okay. But second law states, the ratio of sine of angle of incident to the sine of angle of refraction is known as what we call it is second law of refraction. That is also known as what we call it is Snell's law. Here I am writing the Snell's law. That again another one we call it is the refractive index, denoted by n or mu. Symbol n or mu. That is the ratio of sine of angle of incident to the ratio of sine of angle of refraction is known as what we call it is, that is Snell's law. Yes students, I hope you clear the law of refraction. The same one, that is law of reflection. What law of reflection states here? I'll consider xy with a surface or mirror, okay, then be the norm. Now, OA be the incident light. The part of light get reflected in a same medium. Part of light get reflected in a same medium is known as what we call it is law of reflection. Yes, okay. Now I hope you clear this one. Okay, but here students, but here I'll consider two mirrors. This is one mirror, this is another mirror. Right? Okay now, by incidenting light, how many number of images are formed? The incident angle is 60 degree. Incident angle is 60 degree, right? Okay now, then what is the formula? N equals to that is 360 divided by theta minus. Remember the formula. This is the formula. How many number of images are formed? And if three images are formed, then what is the angle? Different question they can ask. I'll solve the questions. Okay. Remember this. Okay. I hope you clear.
Good afternoon, students. So today I am going to deal with the chapter that is called as coordination compounds or complex compounds, which come under inorganic chemistry branch. Okay, and from this chapter in competitive exams you will get nearly 2 to 3 questions. Okay, so when I start the question, in that only I will explain the concept, and related to that you can solve more number of questions. Okay, so this first question about what concept he is asking, let's see. A group of atoms can function as a ligand only when, means whenever the different atoms combine and form a molecule, they can act as a ligand, but under what condition he is asking. First one, it is a small molecule, it has a unshared electron, it is a negatively charged ion, it is a positively charged ion. And we know that in coordination compounds, whatever the elements or molecules we are writing in the bracket and in the coordination sphere, it is called as a ligand, and ligand should be of two types. One is either negatively charged and other with the lone pair of electrons. Okay, so hence the positively charged ion and a small molecule will be removed. Now the doubt is between either negatively charged or the unshared electron. I told you negatively charged also called as a ligand, but it will be having only one ion, one atom. It is, for example, Cl minus, Br minus, and sometimes 2 or 3 atoms will be there. That is SCl minus, NO2, like that. But maximum unshared electron, that is a lone pair of electron who donates to the transition metal ions, that is acting as a ligand, because the transition metal ions are having empty orbitals. In that, these ligands will donate the lone pair of electrons. Hence, for this question, option 2 is correct, that is unshared electrons. Next one, the number of neutral molecules or negative groups attached to the central metal atom in a complex ion is called as. What is the meaning of this question? In our coordination sphere, if the neutral molecules or negative groups are attached, what that indicates? Atomic number, effective atomic number, coordination number, and primary valency. So briefly I will tell about all the 4 options, then you can understand. Here if I write any compound like K4, FeCN6, okay, in this part is coordination sphere, the outside part is ion or ionization sphere. Whatever we write in the bracket, it is called as a ligand. Okay, and when you draw this structure, that time Fe will be at the center, and these Cn ion ligands will be surrounded by the iron. Okay, and it is indicated by arrow mark. And whatever the potassium 4 ions are there, they are indicated by dotted line, that is 4K. Okay. So here, according to Werner's theory, dotted line are called as a primary valency, thick line is called as a secondary valency, and when we are representing in the form of arrow mark, it indicates the coordination number. Okay, because atomic number is related to the central metal atom, and effective atomic number is related to whole compound, that is Z minus X plus Y. Coordination number is the correct option, and last one, primary valency, it is related to potassium or dotted line. Hence, primary valency dotted line outside the sphere and secondary valency thick line coordination number with respect to ligands. That is the meaning of this question. Now,
so, dear friends, we'll continue the same, the cell. Regarding ribosome, I'm giving some idea to you, and after that, we'll deal with our questions. First, we'll go to our whiteboard. So, the ribosome. Here, ribosomes are appearing like the letter number 8. That is, just I'll draw and show you. In this way, you are observing the ribosomes. The ribosomes are having 2 units. This is first time, this one is second. The upper unit, first unit is smaller one, and the lower unit is larger one. And it is 50S and 60S we are calling. So here, the first one we are calling it as 50S and 60S. The upper unit we are calling it as 40S and 40S. You may ask me, sir, what you are writing this 40S, 50S and 60S? These are the units which are found by the Sedgwick. So, because of Sedgwick, his initial S letter is used here, and we are calling it as Sedgwick unit. Now, the ribosomes, in case of prokaryotic and eukaryotic cell, prokaryotic and eukaryotic cell, if you are taking, they are differentiated. Prokaryotic cell, they are having 70S ribosome, and eukaryotic cell, they are having 80S ribosome. So, the prokaryotic cell 70S, whatever is that, in both the cases 2 units, 2 sets per unit you are getting. The upper one is 40S unit, 40 sets per unit, and lower one is 50S unit in case of prokaryotic cell. But on the other hand, if you are taking a eukaryotic or advanced cells, in case of that, 80S type of ribosome you are getting. The smaller unit will be 40S and larger unit will be 60S in case of eukaryotes. And in case of prokaryotes, the smaller will be 40S and larger will be 50S. So in this way, the Sedgwick units are changed. Now dear friends, just see, the ribosomes are the sites of protein synthesis. Whatever protein is synthesized in the cell or the body, it is totally depending on these ribosomes. So we are calling ribosomes as the protein factories.
Okay, so sites of protein biosynthesis we are calling. So you are already knowing how protein synthesis is taking place in case of the DNA and the RNA, all these things you people studied. But here we are only dealing with the ribosomes. Ribosomes are synthesizing protein and they are sites of the protein synthesis, or they are the factories of the protein synthesis. So in this way, the ribosomes, they are usually found all over the cell, usually freely found in the cytoplasm. Sometimes they are grouped together. Sometimes they are attached with the RNAs. So usually they are attached with mRNA, that is messenger RNA, and they are helping in protein synthesis. So we'll move to the next question now.